I am really excited to be the moderator for this afternoon session, Rangeland, Restoration, and Resilience. We have a great lineup of speakers ahead of us. I'd like to start the session by stating we respectfully acknowledge that we are on the traditional territories of many Indigenous nations and communities, past and present. For millennia, they have worked to protect these landscapes and the life these areas sustain. I would like to thank these original caretakers and acknowledge the ongoing work and presence of Indigenous peoples in Canada today. I would like to note that all of these presentations are being recorded with the exception of the last presentation by the University of Winnipeg. Be sure to take good notes during Colleen's presentation. To our webinar attendees, as we have a large audience, you will be muted for the duration of the webinar. If you have any questions for the presenter, please type it into the chat section and questions will be moderated at the end of the presentation. I'd like to remind everyone that the public session chat on FeedLoop will not be moderated. Our first speaker this afternoon is Carissa Wonkka from the USDA. Carissa will be speaking about rangeland ecosystem resilience and restoration. So with that, I'll turn it over to you, Carissa.
Thanks, Caitlin. And thanks to Carolyn and the organizing committee for inviting me. I'm excited to be here and present some research to everyone. And we'll have a discussion of some rangeland restoration and seeding ideas on Thursday if you want to join in for that group discussion. So I guess I'll start, since this is the rangeland restoration session, I'll start with a little bit of background on resilience theory and then move through some research that we've established to kind of test some of the components of resilience theory and their application to restoration and management. So ecological resilience has become a really hot topic in ecology broadly and in range ecology specifically, giving increasing pressure from climate change, land use change, and invasive species and other stressors on ecosystems. Understanding the attributes that confer resilience is really important from a management and restoration perspective. So there's been a disciplinary shift in recent times, in the disciplinary shift across ecology and specifically in range ecology as well, from a climax-based perspective of internally regulated ecosystem processes to an alternative state perspective. And this shift in ecological understanding has resulted in the emergence of a lot of resilience-based management directives and frameworks. The USDA has established one ecosystem site descriptions and state and transition models used commonly in range restoration and management in the United States. So basically the alternative stable state perspective looks like this in rangelands. And I selected shrubland to grassland state transition just as an example, but there are numerous other potential alternative states, including desertification that happens frequently in the southwestern United States, and then C3 invasion replacing C4 grass dominance is another. So basically alternative stable states occur when a single set of environmental conditions support two or more different stable states, and the ecosystem states are separated by an unstable threshold. In theoretical terms, they call these multiple basins of attraction. And those multiple basins of attraction look like this, where dynamic systems move through multidimensional state space, and the key attributes of this state space are the ecosystem attributes of the different states. For instance, if we were to consider this ball and cup diagram to be grassland and shrubland, you would have this state, the larger state, the shrubland state, which is where many of our rangelands in the United States are now. And the potential is that the state could shift into a shrubland state, but system dynamics of the alternative states are different. And so the negative feedbacks in the system maintain it in the system that it's currently in, for instance, here in the shrubland state, unless a sufficiently large stressor or perturbation causes the state to transition into the alternate state. So ecological resilience is the capacity of an ecosystem to absorb these perturbations or stressors while retaining their essential function and the feedbacks that maintain those systems. So that, for instance, this would mean stay in the same state because of a high level of ecological resistance rather than shifting to the alternative state. So resilience has often been viewed as a pretty vague concept and been proven somewhat difficult to apply, and people have felt that it has had limited capacity in the development of restoration strategies. But recently, a suite of experiments have been published that show that you can use resilience theory to operationalize it to increase your restoration potential. And so I want to describe to you a suite of studies that we established to explore these concepts of resilience and operationalize rangeland restoration. So in the first of these, we sought to assess differences in the relative resilience across an abiotic gradient of soil textures. And you can look at abiotic gradients or biotic gradients in assessing ecosystem resilience to determine relative resilience of a system. So persistence in ecosystems that are characterized by frequent disturbance, such as fire, grazing, and drought, grasslands and savannas being a key example of this, often requires survival and regrowth or repair of tissues because of the frequent disturbance. So therefore, if you think about resilience in a shrubland system, such as the one pictured here, you could think about resilience as a shrubland resilience being high. We would expect a rapid resprouting and return to the previous to disturbance configuration of this system, where you have as much shrub cover before the disturbance or after the disturbance as you did before, within a certain amount of time from the disturbance event. So to test for difference in the relative resistance of an invaded or shrub invaded system in Southwest Texas, we exposed these shrublands to different brush removal techniques that were common in the system. And this is just kind of a visual of the study design. I'm not going to go into a lot of detail, but just to kind of describe what we did here, we looked across a sandy soil, a sandy loam soil, and a clay loam soil. And we applied roller chopping and cut and herbicide, and then also looked at a control plot to compare whether the resilience shifted across these different soil types. So is resilience modulated by soil texture? And this just gives you an idea of what those treatments looked like. We had mechanical treatment, which was roller chopping. This is a large cylindrical drum that is dragged across the soil surface and knocks the trees down. So you can imagine resprouting shrubland. This leaves some meristematic tissue intact below ground while knocking all the above ground vegetation down. And then for our cut and herbicide treatment, we removed vegetation with a chainsaw and applied herbicide directly to the stump of the shrub. And this was thought to have more damaging impact on the meristematic tissue. So I'm not going to go into too much detail on the study design or anything like that, and you can ask questions after. I just want to try and get through all of these different studies because I think the findings are pretty interesting. So I'm going to move right to results here. So you can see that woody plants here recovered on these sandy and sandy loam soils, but not on our clay soils. So we had, this is the change in woody plant cover on your y-axis, and your years on the x-axis. The treatment occurred in 2011. So you can see both cut, herbicide, and mechanical on all three soils were knocked down by our treatments, by both treatments. But on sandy soils, they recovered to this pre-treatment condition where there was no difference between the control and the treated plots by the end of the study in 2013. We saw that similarly on the sandy loam soils, but we did not see that on those clay soils. So the clay soils started to recover and then leveled off and never reached that level of woody brush cover that the controls had. And this just gives you an idea of what the sandy loam mechanically treated plots looked like. They had extensive shrub cover at the beginning, and you can see in the background of this is one of the control plots that was a sandy loam control plot, and you can see how tall and dense the shrubs were, and they did not recover to, or they did not recover to that density on this plot. And this is our clay soils right after removal. And you can see that those clay soils, this is a control plot here. We knocked down all these shrubs, and this is 3 years following our initial treatments, and those ones really did not come back to the same level of density of shrub cover that they had prior to our treatments. And so just to look at this from kind of a relative abundance perspective, we ordered the shrubs on our different soils in order of relative abundance, and mesquite was the most common shrub on our sandy soils and our sandy loam soils. And I'll only show sandy soils here because they were very similar. And then you can see that the black-bush acacia and twisted acacia were next most common. And then when our treatment occurred in 2011, all species were knocked back to very low densities. And when they rebounded, you can see that mesquite was no longer the most dominant species on these sandy soils. And instead you had other species that came up in relative abundance and took its place as the most abundant species. So the presence of these subdominant species that contributed to ecosystem function in similar manners as mesquite, but responded differently to these environmental changes or disturbance, provide higher adaptive capacity in this system. So adaptive capacity is a component of resilience that's derived from the traits of the species present. It's been linked in the literature to a combination of evolutionary potential, life history traits, dispersal ability, phenotypic plasticity, those sorts of traits-based ideas. And the response diversity increased by whitebrush and hackberry in this system under the sandy soil plots. So they have large root crowns, and that increases the amount of meristematic tissue that's left behind, especially in the roller chopping plots. And that tissue is available for respreading following the mechanical disturbance on sandy soils, specifically because of our increased infiltration rate once some of these brushy species were knocked down. So because of their specific traits, they were able to take advantage of a pulse of resource in increased moisture and rebound in the system and regain dominance, making this system highly adaptive to our brush control methods. Whereas you can see on these clay soils, reductions in mesquite dominance weren't compensated for by the other two species. And that was because of the lower infiltration rates on this soil type. And so mesquite or hackberry and whitebrush weren't able to compensate for loss of mesquite because there wasn't this pulse of resources on those clay soils. So in rangelands with alternative grassland and woody vegetation states, knowledge of these topographic conditions, soil conditions, biotic conditions, and environmental conditions that decrease the ability for the invaded shrubland patches to absorb disturbance provide a much needed basis for prioritizing our restoration efforts. So we saw that the resilience of the Prosopis acacia rangelands to brush removal varied across this range of soil types, with the shrublands showing contrasting abilities to recover, suggesting that soil texture does indeed modulate shrubland resilience to perturbation. And it interacts with the traits of the dominant species to determine adaptive capacity. So those species traits are very important in understanding this interaction between soil texture and resilience. So what we're able to do here, and we created this map using soil types, and we mapped the sandy and sandy loam versus the clay soils across the county that the study took place in. And this allows restoration practitioners and range managers to focus their restoration efforts in areas where they're going to have a bigger bang for their buck. So if they focus on these clay soils, the mechanical and chemical treatments, which can be very cost prohibitive, will have more effect and they'll have a longer effect. And so by prioritizing these, they're able to keep costs down and focus really where they're going to have a good result. So as we saw in the case of whitebrush and hackberry, these species-specific responses of resprouting shrublands complicate our ability to target the conditions necessary to overcome the resilience of shrubland systems when we're restoring them. So identifying the traits that conferred resilience for these species was pretty important and can help identify the best conditions for effective restoration solutions. And so another set of studies that we've been focusing on is to look at trait-based analyses, because they offer a lot of promise for restoration and making transferable restoration decisions across ecosystems. So quantitative trait-based analyses have emerged as really important tools for predicting responses in community composition as a result of disturbance and stressors across a range of conditions. They are physiological, morphological, life history characteristics that determine the plant's response to its environment, both abiotic and biotic components of the environment. And so we have effect traits that influence ecosystem processes, and also response traits that describe species-specific responses to abiotic and biotic factors. And these measurable traits they're linked to ecosystem processes that drive transfer of energy and materials, such as nutrients and water, fire dynamics. So by being linked to ecosystem functions, we can really start to make some predictions about what will happen in an ecosystem following disturbance if we take a traits-based approach. So quantifying covariation among the traits and across scales can really help to provide a generalized approach to assess whether there is environmental context dependency in this covariation. They're important tools for predicting community response, and although they're parameterized through experimentation in particular locations, they provide this theoretical link between community dynamics and ecosystem function. Oh, and I just want to mention on this previous slide, I have this tri-plants database listed here. That's a really useful database. It's a network of vegetation scientists. It's headed by Future Earth and the Max Planck Institute for Biogeochemistry. They provide a global archive of curated plant traits. They have 5.6 million traits and over 100,000 different species. So if you're working in a specific system and you want to know what the dominant traits in your system are, you can look them up in this traits database and not have to measure all of the plant traits in your system. You have some idea of what they are from that database. And so the study that we wanted to set up to look at plant traits was a pipeline reclamation study. So disturbances that clear existing vegetation from an area, such as pipeline construction, they create opportunities for invasive species to expand and potentially spread into intact ecosystems. And so in order to reduce the potential of this spread along pipelines, the reclamation should seek to restore native plant communities that are resistant to invasion. And so a functional traits-based approach can improve our success in restoring these by providing a means for applying ecological theories of community assembly and resilience to the selection of the species that we seed or plant in order to meet our restoration objectives. And so there are two different theories that have been implicated in invasion dynamics, and I won't go into them too much here, except to say that limiting similarities is based on selecting plants with similar traits to the invaders, the potential invaders in the system. And then competitive hierarchies is the other community assembly theory that is often called upon to think about invasion resistance. And that suggests that some traits are competitively better than others. And so if you select native species for plantings that have higher levels of those competitive traits, then they will exclude potential invaders. And so this study, we just started getting it going in greenhouse form. We're also going to look across multiple scales. And once we have some results from the greenhouse study, we're going to transfer that to a plot study and eventually a landscape scale. And this is an important concept in resilience theory because of cross-scale interactions. So processes at one scale feed back to resilience at other scales. So you can't just look at study at one level if you're interested in the resilience of an ecosystem or the resistance to invasion. Because a plant community, for instance, that is resistant to invasion at the community level might not be resilient to larger scale drivers such as fire or climate change or changes in the regimes of fire and climate. So it's important to test resilience at multiple scales. So we don't have any results to share with you yet, hopefully soon, but just kind of putting it out there as a way that you can use plant traits approaches for reclamation. So you can select species based on the resilience of their traits to perturbation and stresses, whichever ones are important in your ecosystem. And you can restore the ecosystem processes that are necessary to maintaining negative feedbacks that increase resilience and resistance. And this increases the transferability across ecosystems and species so that your experimentation can kind of pinpoint these approaches that are going to be useful in multiple ecosystems. And just briefly, I know I'm running out of time here, but I wanted to talk about a third component of resilience, that is hysteresis. It's a very important one for understanding resilience and trying to set up these experiments to determine restoration strategies that will work in your system. Hysteresis is characteristic of alternative states where these changes in the ecological drivers result in an alternative state, but just reversing that change in those drivers doesn't immediately restore the previous ecosystem state, because not all alternative states are equally stable. For instance, it's a lot easier to move from a grassland to a shrubland state than it is to reverse it back to a grassland state. So this has led to this understanding in ecology and range ecology that shrubland encroached grasslands can't be restored by restoring the processes that maintained the grasslands prior to the transformation. And so a lot of people want to use fire to restore grasslands from shrublands because it's cost effective. Those mechanical and chemical treatments can be very expensive, but people see this as impossible, as you can see from the quotation I have pulled out of this very popular paper in ecology. But we hypothesized that the hysteresis in these systems might require an increase in fire energy to shift shrublands back to grasslands with prescribed fire. Typical prescribed burns might not be sufficient to overcome hysteresis in the system. And so we set up this study to look at the impact of high energy fires on both Juniperus virginiana and Prosopis glandulosa, which are important invading species in the Great Plains of the United States. Just to talk a little bit about some of the things that are important when you set up a study like this. We wanted to push the limits of fire behavior, so we added fuels to create high intensity fires. In some cases, in experimentation, we looked at conducting fires during droughts that would increase the intensity and the stress on the plants. And then you also want to measure the plant exposure to fire with fine resolution data so that you can tie the exposure that the plants are experiencing to the thresholds that they might cross. And then in the same way, relating demographic response to plant physiological responses allows this traits-based approach where you can see if these thresholds that have been overcome with our high intensity fire are related to what's going on in the plant physiologically. And by relating it at that traits level, you have a more transferable result from your study. So just to show you a couple of results that we saw from these experiments, when we looked at fire and drought together and had extreme fires because of the drought conditions and the low fuel moistures and stressed mesquite trees and other species, we saw 35 to 55% reduction in the density of resprouters following these extreme fires. But the mortality varied among species, and so it's important to look at the species-specific response and then tie that to physiology. And in another study, we did that. We attempted to look at mesquite persistence, and in this one, we increased the fire intensity by adding fuels. We added downed woody fuels, volatile fuels to some of the plots. Those were our high energy plots that you can see here on this graph. And then to the others, we just had ambient fuel conditions, added hay for consistency, but at a low level. And you can see that this high fire energy really knocked back resprouting in mesquite. And this is only a couple of years out of the treatment, so we're not going to necessarily be able to say this is the total amount of mortality yet. Mesquite can resprout for several years following fire. But we did see quite a bit of loss of resprouting vigor, and this has translated into mortality thus far. That's almost 100% in the high energy fires and very, very low in the low energy fires. And just in keeping in line with the whole scaling up, we also conducted this on a landscape scale. But in this case, we were looking at eastern red cedar, which is a juniper species that's invading in the central plains. And it's really important to think about this one from a landscape scale because it's not a resprouter, but instead its prolific invasion results from propagule pressure. And so we had a landscape that was entirely invaded with these juniper trees. And we were able to work with a landowner group who was doing a lot of large-scale burns across an ecosystem, the Les Canyon Rangeland Alliance. You can see their website listed down here. And this is a picture of one of their fire operations. And these guys really wanted to ramp up the amount of the landscape they were burning to try and combat this propagule issue and see if they could restore the entire ecoregion to grassland. And so they were pretty successful with that, and we saw juniper mortality was almost 100% in areas where they added juniper fuel that was dried and added to juniper clusters. And so they were able to overcome the hysteresis in this juniper rangeland by adding fuel, whereas mortality was very low in patches without the added fuel. So you can see this hysteresis is important because you need to overcome it in order to do your restoration. And if you're not reaching these thresholds that you need to overcome the hysteresis, your restoration won't be successful. And so when you look at all of this suite of studies that focus on hysteresis, the important things really are to push the limits on your fire energy or whatever inputs they are that you're trying to use to overcome the hysteresis, and make sure you're measuring the things that are going to help you make these studies more transferable. And so when you think about all of this as a whole, there's really a lot of opportunity to explore resilience as a basis for restoration. And I think given that it provides a theoretical basis, it can really help create transferable restoration solutions that are long-term sustainable and effective. And even in the case of using fire rather than mechanical methods, some lower cost kind of solutions. And I just want to acknowledge everyone that was instrumental in conducting all of these studies and my funding source, and would love to take questions if I have some time.
Awesome detailed presentation. We do have a few quite lengthy questions here. So I know I told you I wasn't going to put them on the screen, but I'm going to. Yeah, so we will just put them up here. Okay, so the first one was any data collected on the negative effects of high intensity burns to other plant species that would be desirable to keep on the restoration site, such as grasses, forbs, etc.?
Yes, that's a great question. So as part of all of these studies, we also looked at the response to grasses, because that was a question that we got a lot in areas that were conducting these high energy burns for restoration. In our most recent study, we actually tracked the buds of specific grasses, looked at their meristematic response to these high energy fires, and we did see that there is potential with some of these more volatile fuels when they're really loaded up over a specific spot, that you could have a kind of a shift in community composition. So we saw our bunchgrass species, they had very deeply buried meristem, and so they were able to come back regardless of the fire energy. They responded very quickly. The buds became dormant, and they went into early dormancy and overwintered, and that was a way of protecting the buds from any negative impacts. And soil is a very good insulator, so the fire energy didn't quite reach down enough to cause mortality of those buried buds for the bunchgrass species. We did see a little bit of mortality in our rhizomatous species because they have buds that are closer to the surface, and it was pretty small. It was about 10% mortality on the high energy plots for the rhizomatous species. And so that you might think about ecosystem dynamics and how you could have a shift in dominance of species over time. But overall, there was really no loss of productivity. The productivity remained the same. We just might have had a shift to more bunchgrass species than rhizomatous species for a short period of time. I imagine that the dynamics will shift with time since fire as well.
Thanks for that answer. I know we're a little bit over schedule, but I'll just ask one more question. And then to all of our listeners whose questions didn't get asked, maybe you can connect with Carissa afterwards. Okay, thanks, Carissa. The last question is, how well did the herbaceous species respond in each soil? It seemed the clay had better grass recruitment and therefore more competition against the woody species. Would the mechanical removal do more damage in sandier soils and thus more damage to herbaceous health? Do you have any comments about that?
Yes, absolutely. That is very insightful. We did indeed find that the sandier soils, when they did that roller chopping, we had grasses being churned up and a lot of roots exposed and a lot more mortality. And so while we had the same species in both types of soils, the relative abundance of them was different. And so some of the more ruderal species, I guess, were more prevalent in the clay soils. So not only did we have increased mortality related to these soil textures, but we also had different suites of species that were able to respond to the increase in moisture better on the clay soils. So there is some interspecies competition dynamics going on there as well. Yeah, that's a very good point.
Thanks for that answer. And thank you so much for the really informative presentation. And thanks for your time today. So with that, I will make you an attendee and call up our next presenter. Okay, so before I introduce our next presenter, I do have to mention it would not be virtual conference without technical issues. We've experienced a little bit of that today. So our next presenter is Julie McKenzie. Julie, if you are on the line, which I'm hoping you are, you can unmute yourself and hopefully begin your presentation. Julie's presentation today is called Can It Really Grow? How We Harness Seeded Native Species on Our Farm. So we'll just hang on for 1 minute and see if she's able to get on.
I think you can hear me. Can you hear me?
Yes, we can, Julie. Thank goodness.
I'm going to leave the web camera off, though, just because of the internet conductivity problems today. Is that okay, ladies?
Absolutely, yes. And I'm going to turn mine off too. And yeah, we'll just focus on your slides and let me know if you need me to advance them for you too.
Well, I will get you to advance them. That would be perfect because I am going on my phone right now.
Okay, awesome. Well, I'll let you take over.
Thank you guys very much. I feel bad because Carolyn didn't maybe get to do the introduction she was hoping to, but I'm happy to do that. My name is Julie McKenzie. I'm a professional agrologist, and I've had a long history with native prairie and seeding and different things like that. But I want to talk to you today about Can It Really Grow? How we harness native species on our farm here. So I'll get you to advance it there, Carolyn. So thanks for bearing with me with some of these internet problems we've had today here. So so here we are. We're at Hazenmore, Saskatchewan, and this actually is in the brown soil zone here. You know, where we are here, we get the tail end of Chinooks. Today, I think we're sitting at +2 right now, and really dominated by grain production in this area, in the immediate area. We're north of Grasslands National Park, and usually we get 12 to 16 inches of precipitation a year, but you can see sometimes it gets quite a bit drier than that. So we'll advance here, Carolyn. So I grew up actually east of Saskatoon in the St. Denis Hills, in Fescue Prairie area there on a mixed farm. And now I farm down here at Hazenmore. We're actually a mixed multi-generational farm. My father-in-law's family homesteaded in Hazelmore. We farm with my husband Glenn's dad, or my husband Neil's dad Glenn, and his mom Liz. We crop over 5,000 acres and have another 3,000 acres in hay and pasture. Our cow numbers really fluctuate, but this year we're right around that 275, 300 head calving out here the next couple, probably about 6 weeks or so. And while a third of the herd stays home for the summer, we send 2/3 of them off to summer camp yearly. So they go all over the province to summer camp. I also ran an ag consulting business from home, and that's kind of where some of my prairie work and background is. Right now, the work I do has a focus on ag water management, which does include drainage and also work with forages. So this really allows me to focus on farm work during our busy times and as my clients are busy when I am. And I guess that kind of sets the stage for talking about Can It Really Grow and our farm today. And I'm going to talk about a couple different native seedings we've done here over the last 10 years and talk about kind of how, as a practitioner, you can bring some of what you're talking about today onto the farm. And I think that that's where some of that transfer still can happen and still needs to happen. I hope this kind of gives you that inspiration to move it onwards from maybe where a lot of you are today. So we can advance it there, Carolyn. So how it all started. Well, we have we have two different seeded native pastures, and it started, well, we had burrowing owls in the area. Native seed was a low price, a good price, as I call it. That's the farmer in me, the good price. And there really were programs that were readily available for BMP practices. You know, land prices here were very reasonable, but commodity prices were really low. There was land that we had that fit with seeding pasture, and we needed to work to ensure that we had a forage supply for our growing herd. Neil and I both do enjoy cattle work the most, but honestly today we enjoy both sides of our operation equally, and hence why it's shaped this way and why our operation is shaped this way. He's actually cleaning durum seed today, so we'll move on here. So we, like I said, we have those two different things. And I don't know, Carolyn, are you guys able to do the poll from there that I had sent, or are we technically challenged today with that? We might be challenged. That's okay.
Don't worry about that.
That's okay. So really where I want to kind of go with this is we had some big influences for us and why we decided to seed some native species. In the early 2000s, Mike Schellenberg and Isle and Iwasa were doing some really amazing, insightful work with their teams out of the research station at Swift Current. So Spark is what we call it around this neighborhood. And at Spark, they're looking at native species and seeding, and they were seeding them with success. And seeing that success that they were having and knowing what was applicable in Swift Current could then be applicable to us. Those were really a lot of the guiding things and the guiding things of why we decided to seed native species. The confidence that those two gentlemen brought and their teams, they have some great teams behind them there. That confidence they brought, seeing purple prairie clover as one I always hit on was really the only reason that I gave it a chance. Being able to see those plants and see the mixes that they were doing was very helpful. It really guided this decision on what to seed on our farm. And at that time too, I was doing a lot of work in forage conversion in my career and was learning from many different people along the way. I was seeing success in green needlegrass stands and wheatgrass stands, at Gravelberg and in East End and in the Missouri Coteau. And also too, there was work that Laura James and her crew were doing down at Grasslands National Park with other natives that was helping us learn too about, what was working and what wasn't working. I also really need to thank Neil for going along with my crazy ideas and the crazy mixes that I was coming up with. So we'll advance it here. So So we have two seedings. The first one I'm going to talk about, this is Blake's, and that's how I'll be referring to it. This is actually native pasture here. Not this Christmas, but last Christmas, when you live where there's Chinooks, this is what you sled on. In the far background there is actually our seeded native there. But what our goal was with this here was a rotational system for that small herd that we had at the time. It was a 50 herd. 50 head herd, 30 to 50 for us at the time, and Glenn had about 80. And we've grown quite a bit since, but we owned very little land, and we're trying to figure out how to make this native pasture function better. It was smaller, and how to make the whole system function. And our means to that was a seeded native project. Actually, we worked with Nature Saskatchewan, actually, with some HSP funding that they had at the time, because there's burrowing owls in this area, and actually on some other property of ours not too far away. So we'll advance the slide there. So what we did, and this is kind of that. Sometimes it all works out great. This was family land that we were farming that's seeded down, so we knew what the history was. It was managed. 2009 was Chemfowl, and then it was in 2010 it was green feed. So we seeded in 2011. We had a pre-seed burn off. Seed placement is really important to us. Very important. We mix it with a little bit of wheat, our seed, just as a carrier. We seed it with our air seeder. At that time, I think it was a 50 foot or 55 foot. Probably 50 foot we were running at that point. We actually mix our seed in our carrier, which is wheat or barley, usually wheat, actually in these mineral tubs, and only put like enough to seed about 5 acres at a time. So it's a really long process, and you have to have a very patient husband to do this process. But what we've got is our soil type, brown soil. It's loamy. It's rocky soil, actually. What we seeded out here with our mix is we went with a 40% green needlegrass, 10% northern wheatgrass. We put 10% slender wheatgrass in this mix, and 25% western wheatgrass, and that 15% purple prairie clover. And that's because it needed a native legume, and Mike Schellenberg and Alan Awasa had given me some faith, so we were gonna try it. It needed to be in there, right? So this 40 acres that we seeded in this project at the time, it was a separate strip. There was some tame grass that we'd seeded adjacent the year before, 2 years before there. And we didn't have a lot of weed pressure in this field. There wasn't a lot of thistle or kochia, and kochia here is the bane of our existence. We're constantly fighting it. There is downy brome in the area, and there was some here on this field. So we'll advance it here, there, Carolyn. So then what happened? Well, this is a year later, actually. This was late July, early August 2012. And I know because I was 7 months pregnant with Noah. So that was pretty easy to date these pictures. And so, we had great catch. This was seeded, in June, and yeah, it rained that year. But it was a good catch. And we were able actually to graze it that year after it was seeded out there. So we'll fast forward one there. I did mention downy brome before, and while we did find a couple patches in the few years following seeding, they vanished from the pasture as it took over. And you notice I'm referring a lot to like pasture and seeding and different words, and the words I'm using are very much the agronomic words for this, for restoration or reclamation more so, or seeding, right? And this, our goal wasn't like an ultimate restoration exactly. We're seeding natives, and I think that's the important thing there. But with that, I guess kind of going back there, we don't see any downy brome right now out there with the seeding that's there. So we've got some purple prairie clover. that really came through. We were very impressed with how it grew and what we've got out there now. The fence line picture that you see is actually on the right. We have our tame seeding, and on our left here we have our native. So there's actually like a strip of tame that's on the native side there, just because the way it's kind of creeping in and the way the fence line is there. And that was taken that first year in early August. You can see the lentils are turning. So we'll flip the slide there. So this is August 30th, 2019 there. I really wish I had a picture of the purple prairie clover in bloom out there. It's been phenomenal for the last couple of years. And, you know, as you see from above, that seeding recruitment is really high. The cattle really do go for this legume. We've got, you know, some older sticks out there. So, you know, that sometimes happens, but there's not much left. And I guess that's what we're trying to achieve there is we want some stuff to catch that snow. While we still have bare ground, as we're not going to achieve that, you know, native range, we're really happy with the cover that is there, and the growth that we're getting every year. Yield wise, we're getting about 0.8 to 1 AUMs per acre on it, I estimate. And really what it's done for us, it's allowed a remnant prairie area to have a parcel of native species that can be managed with it for more benefit. So that's what we're seeing out there. If you want to fast forward one, Carolyn here. This is the then and the now. So the then is on the left-hand side and the now's on the right-hand side. Like, so there's a then purple prairie clover, and now that's Noah. He was the one I was pregnant with there before. So we've got Noah there in front of it. So he's an 8-year-old. So really we see plants that are increasing in size and increasing in significant or increasing in density significantly, really. You know, our management still sees slender wheatgrass seedling recruitment happening and new plants out there. And so actually this picture of me bending down and the picture to the right of it is actually pretty close to the exact same spot. It just so happened. You can see the hills in the background are very, we're in the same place. So we see what it looks like that 10 years later. And we'll flip one more here. So every year, how's it used today in our long-term plan? Well, every year it gets used, with the exception of 2019. There was carried over till 2020, as we had a herd contraction in 2019. You know, the pictures you're seeing from that 2019 is before it's used, but usually every year it's used at that time of year, and that's what it looks like before it's used. How it's used is it's the orange star, and it gets used with that coulee run that's there in the fence with it. The green stars are tame, so we go from tame to tame to tame to back to tame first, and then we switch to the orange star. To the north, we also have some more coulee run of the neighbors that we use there. Depends on the time of the year. So our long-term plan with this is to just keep using it the same, using it with our remnant prairie there through the coulee, and just trying to manage it together and hopefully still have some of that slender wheatgrass recruitment that we're having, and we're getting lots more purple prairie clover. Our density's really increased out there, and we are really happy with the weights of the calves and the production we're getting off of this area. Okay, we'll switch to Carolyn. So we have one other seeding that I'd be remiss if I didn't speak about. This was the same year in 2011. Actually, we seeded it. Our goal is to develop a new pasture there too that could allow for that herd expansion, that on some land that was purchased at a reasonable price, and there were some salinity issues out there. We needed this one to be used at any time of year with a potential for a rotational system because it wasn't adjacent to anything else. It's about a mile from where Blake's was there. We wanted a long-lived pasture, and remember, I'm talking farmer language, so pasture versus, you know, actual native seeding. You know, it's and for us, our means to this was we access the farm stewardship program funds to seed this pasture here. We'll flip one more here, Carolyn. Thank you very much. So what we did, And this one here, the weed competition was quite high on it. We weren't the ones who had seeded it the year previous. We went straight in and seeded into it after acquiring it. It ended up getting seeded a week later, maybe 5 days later. It was pushing the beginning of July when we actually seeded the plots. We've got some Saskforge Council salinity plots out there too. But there was some trash out there, and there was some kochia competition. We went at this one a little bit differently. It was a mix between tame and native, and that's why I wanted to talk about it a little bit here. We seeded about 25% alfalfa, 20% green needlegrass, 28% meadow brome, 22% western wheatgrass, and 5% slender wheatgrass out there. We wanted species that were going to be able to be used at many different times of the year, and complement each other. And native seed was really affordable at that point in time. So we can switch here, Carolyn. So what was this one here? Well, we waited, and we waited a lot. It was so different than the other field, even though it's a mile apart, but it had different history on it. We contemplated breaking it up, and we considered leaving it, and then we drove some more, and then we didn't want to pay for more seed to seed it again, and well, maybe it would come, and then we drove it some more, and it was it was 2 years and trying to decide exactly what we were going to do with this seeding out there. So we'll switch, Carolyn. And then it managed to come, which is a good thing. This is what it looks like from above here. So up is north, of course. On the east side, that's where Saskforge Council salinity plots are, and more towards the south and the west is where it's mostly natives. That native tame mix that we seeded there. So what we did, well, we built a dugout, and we had it fenced, and we kept going, and it started to come through 2013, like I said. Oh, then we had cows on it for part of that summer, and then the cows started to die some more. Well, we determined that there was bad water on it. All the springs through it in the dugout. We have a problem with bad water down here, and it wasn't a place that we had thought. And at that point, too, people weren't picking up on bad water. So we then had to switch what we were doing with this. We switched to haying as an option. Well, I don't know if anyone's hayed green needlegrass. It's not high production, but I guess I have green needlegrass growing all over my yard lots now. And in 2016, we added some more alfalfa, overseeding it with our heavy harrows out there. And really, we've been haying it ever since. And we'll switch here, Carolyn. What it looks like now. It's beautiful. We're really happy with what it looks like out there. It's not high hay production, that's by any means. We've got a really good catch of wheatgrass out there. The meadow brome and the green needlegrass really complement each other, as you can kind of see what it looks like out there. And we really, from what it looked like to what it looks like now, it's a really nice catch. You can switch, Carolyn. You can see what this looks like. This wasn't this summer, it was the summer before. So this is 2019 out there. There's some good production out there of native species. You can really see a lot of the native species and a lot of the wheatgrass. And the green needlegrass has been very impressive. You can move through to the next one. So how's it used today, and what our long-term plan is? And I think I wanted to put this one in here because it's a little bit different perspective than maybe some of you have looked at maybe seeding natives, because it is mixed with tame species out there. But like I said, this has been hayed yearly because of that water issue. And some years when that snow's adequate, the cows have also grazed the field later in the fall. And in 2021 here, I anticipate we'll do one of two things. We're either going to hay it and break it up, or graze it first thing in the season and break it up, or else we're going to decide to keep it and just use our water infrastructure that we have from our grain farm to support the cows out there. We'll be trucking them water because we've got the semi and the tanks and all of that that's used all the time. So those are our two options out there, and I'm not sure exactly what we're going to do yet. It always is a evolving situation. So we'll switch there, Carolyn. Now you may ask why we haven't seeded natives in nearly 10 years. Because I highlighted ones from 10 years ago. Just the situation we're in. We bought a farm that had quite a bit of grass on it. We've managed with the pasture situation in the province. We have cows going to many different pastures, and we're bought into those corporations, those pasture corporations now. So that's a big part of it there. And really, we've been using annuals a lot for our hay production or our forage production. So we haven't had anywhere where we've really been looking to seed in the last couple of years, except for actual hay. And we were tending to go with a straight alfalfa at that point. Do you want to switch it there, Carolyn? But the question is, will we again? Well, I suspect if we do, it will be along this lovely chunk of remnant prairie that we have here. When I say remnant, I think this one's 120 acres maybe. And what we would do, I think, is we would really go with that green needlegrass, western wheatgrass, and purple prairie clover. We've really seen the agronomic advantage of these species are good for us. Their adaptability has been good for us, and their ability to complement what we've got out there, where we're at. It's a needlegrass community. And really, I think that's where we'd go at with it if we were to do it again, and will we? Do you want to switch it one there, Carolyn? But the question is, will we? And this is, and can, the question more maybe is, can we? I've got the 2011 prices of what we paid. I actually found, with the help of Rebecca, I found the invoices, and I actually found invoices when I was going through stuff too. And so I did it, what the prices were in 2011 and what they are now. And those 2020 prices are from the Sask Forage Council reports that come out in January every year, and they look at prices in Saskatchewan. And really, in 2011, it was $58 an acre to seed. This was seed. And if I was to do it again today, it would be $136, $140 an acre. And same with Tebow's. When I look at that with the tame and native mixed together, at that point, we're at $44 an acre. And now we're up in that $109 an acre. I really can't, I can't pencil that out. And the risk that goes with it and the price that they are. And so would we do it again? Potentially, but even the seed that was pretty affordable at that time, at that green needlegrass, we're looking at 4 times the price. And that one really comes on strong. And really agronomically is a very, I've been very happy with it agronomically. So, purple prairie clover has increased almost the least that way. So really, when asked if you're going to seed again or how to encourage producers to seed, this is where we get the hang up there. You want to switch it there, Carolyn? Our greatest consideration for us, and what I would pass on to anyone looking at seeding it, is look at some complementary species. If you're looking to getting some natives or on your place, there might be some tames that can complement it. And looking at seeding natives as a complementary species and trying to move them mainstream, maybe to buffer some of that, the adaptability things we're starting to see and to move into and consider. Location where it makes sense, that's a big thing. And looking at what production goals and production needs are. We really strive to apply standard agronomics and good weed control. And we know that was the success on Blake's versus Tebow's, was that successful and good agronomics prior to seeding, and that ability, can we wait? And sometimes we can't wait these days. And waiting for something to grow, we see that in the province when people are looking to moving to annuals. Well, it's that time to wait. We'll flip there, Carolyn. So I guess kind of to wrap up there, we've had a lot of species that we've tried at different times here. and there's lots that are evolving to adapt to the climate we have and adapting better here. And I think using some of these native species can work on farm. It's worked for us. I would definitely do it again. They provide some adaptability, but it's to overcome some of the issues that there is with pricing right now and that. But there is the ability, and they're not hard to do, and they're not hard to grow, and they can flourish and really still do there. So, and with that, I'll turn it back to Carolyn.
Thank you, Julie. Really awesome presentation today, and thank you so much for dealing with all the IT issues that we had leading up to this presentation. I'm just going to put up, I think we got time for one or two questions, if that's okay, and then we'll move on to our next presentation. So
I'll need you to read them probably, Carolyn, if that's okay.
Absolutely. And this is Caitlin, by the way, but we're both on the line. Yes. So the first one is from John Morgan, and he's wondering, where were the grasses and purple prairie clover seed from?
Yeah. So we source everything. We work with North Star Seeds. So the green needle grass was some of that time there was a lot of ecovars around. And so that one was an ecovar. But they all would have been sourced from either Saskatchewan or Manitoba at that time.
Thanks. And then our last question is from a listener named Sarah, and she says, I may have missed this, but did you do any pre-sowing treatments to the purple prairie clover? And comments that it looks like germination was very good, and I agree with her.
It was very good, and seedling recruitment has been phenomenal since. Like the natural seedling recruitment out there, we're getting new seedlings recruited yearly out there. And so, yeah, those ones were scarce. They were scarcified when they came. But other than that, we did not do any treatment to them at all.
Okay, well, that's awesome. Thanks for that answer. I think we're going to pass it over to our next presenter. So thank you again, Julie, for the awesome presentation. And we really appreciate the time that you're able to do today. There's still quite a few questions in the chat box. And if you are on FeedLoop, you're welcome to reply to some of those questions just by chat there too. And
Sure.
I know Carissa did the same too, since we're tight on time. Thank you again, Julie. Okay, and our next presenter is Kanzi. I'm really pleased to introduce Kanzi Fox from the Blood Tribe Land Management, and she will be speaking about holistic ecocultural restoration based in Blackfoot science to mitigate and adapt to climate change. Kanzi, are you there? Can you hear us? Kanzi, if you're there, you just have to click on the AV pod to unmute yourself or turn on your webcam.
Okay, I think I got it.
Yes, we can see you now. Perfect.
Okay. All right. Okay. Hello. Mistuana go kabetsit tibiaki. My name is Kanzi Fox. I am the environment manager with Blood Tribe Land Management and a member of Kipa Kainai Ecosystem Protection Association. So I just want to thank the workshop organizers for the good work they're doing. I know it's not an easy task to run, especially online. That's what we're trying to figure out for some of the stuff we're doing. And I'm grateful for being able to present to you all today. My presentation is about restoring our important ecological and cultural ecosystems, and that's going to be based in Blackfoot science to mitigate and adapt to climate change. So to go next, am I doing that or is? Sorry, I just need to figure out how to go to the next one.
Oh, that works. You found it.
I just wanted to show a video that we produced from our community. It's a perspective that some of the community members had on climate change. And if you just want to start that, Carolyn, or... Okay.
Yo, hey, hey, I heard about global warming when I was maybe 16 or 17. There was an old lady, her name was Dwatsky, and this uneducated old lady said people think the earth is just floating around, but there's a cover, and she likened it to a womb covering. The news came on that a spaceship had landed on the moon, and that old lady said, oh, my poor children. She just about started crying. She said, everything's gonna be different for you. They made a hole in the womb covering of the earth, and your weather's all gonna change. Lo and behold, this old lady was right.
Every society, for instance, claims a territory. So we have Blackfoot territory. Okay. And within that territory, we develop a culture, okay, in relation with the sky, the animals, the plants, and so on.
As Blackfoot people, we follow the seasons, and we practice reciprocity and renewal ceremonies. We have a connection to the sky people and the ground people and the water people and Matapi, us as people, Kunatapi. And you can see changes in weather patterns, you can see changes in animal behavior, changes in the flight of the birds, and the water species are being affected by climate change. When we practice our renewal ceremonies, when we go out to harvest and gather, to practice our Aboriginal right to harvest and gather, whether it's medicinal plants, herbs, roots, or harvest the animals and birds that are part of our societies in bundles, it's getting harder and harder to find and locate certain plants, certain animals that are included within our bundles and our so that we can practice our ceremonies.
And in our traditions, the beaver bundle keeper looked out for the environment. So we had a sacred duty to Mother Earth through the beaver bundle. You know, we sang all the animal songs and honored them. The rocks, everything is honored in the beaver bundle. And it's, you know, it's heavily leaning towards our environmental safety. You know, the animals don't, you know, going up in the hills, but because of the fires, they're all coming down. And you know, all the fires that they're having, I mean, just stop to think and how it's going to affect you.
When the climate changes over time, then that predictability, all the relational networks that you have with animals and so on, start to change. Okay? So in other words, the eagles come a little bit earlier. Maybe they leave a little bit later. You know, the buffalo doesn't quite move as they used to be. Okay? Well, then that starts to kind of bring about a little bit of cultural chaos, if I can put it that way. See, so that's what climate change to me is all about. Taking in all this ecological balance, our relationships, and in the end, it affects our culture. When we hear the first thunder in the spring, and it used to be late spring, that's when all the bundle openings start to happen. Now we're hearing thunderstorms, and we're hearing the thunder and lightning in March. See? Well, that really throws off the timing that we're used to. See? And that's what I meant in the previous statement about bringing about cultural chaos. See? And, you know, sun dances, for instance, happen when the berries are just ripe, the Saskatoons are just ripe. Well, now the Saskatoons are taking a little bit longer. So in other words, hey, we may have to change the times of our sun dance ceremonies and so on, and what we pass on to the younger generations. But if things are changing, well, then the old knowledge starts to fall on the wayside because new things are developing. That's what climate change is to me.
Hi, so can everybody hear me okay? I wasn't sure if that video played all right. Okay. So yeah, my end, I couldn't see the video very often.
Oh, okay. It's now back to your slides.
Okay, thanks. I'll just leave my video off because I'm getting these warnings of bandwidth and stuff. But our video was produced with the community. And I really like the term that Dr. Leroy Littlebear used there, the cultural chaos, to convey our current situation, what's happening with climate change, which is also synonymous with ecological chaos. You know, those relational networks that we know and have evolved with have changed our ways of knowing that are based in reciprocity, renewal, and ceremony. And they all align with ecological balance and sustainability, are all being less and less predictable with climate change. Okay, so next slide. So as I didn't really introduce my First Nation, but I'm from the blood tribe Blackfoot or Niitsitapi, and we have always practiced Blackfoot science. It just wasn't always called that. Observing and participating in the land around us, with the prairies, the mountains, and all our relations. The evolution of the now endangered grassland was balanced with the practices of bison grazing and prescribed burning and sustainable harvesting. I'm not sure if everybody's familiar with Dr. Robin Wall Kimmerer, but I just love how she refers to reciprocal relationships as gifts, and those gifts are what we should share with each other and with the land, but responsible and accountable manner. So that's a lot of the work that we're doing is based in these fundamental values and beliefs. Okay, next slide. So rematriation, I'm not too sure if that's a familiar concept, but it's similar to repatriation, but it's also inclusive of a sense of bringing things home. And when we braid together modern Western science and traditional ecological knowledge into a tapestry of life that is dynamic, holistic, and reflects our community life values. So it's all about restoring and healing our relationships to the land. These sacred practices were taken from us in the context of colonialism. Our work is to bring these practices home again, and bring it to our community so that some healing can take place. So in that first picture, you can see Ini, or bison, the buffalo. We are now bringing home our buffalo. It's a cultural herd that will be in our north end grasslands in about a week. So we're very excited to welcome them back and see the positive changes that occur with that. Fire, we're working with partners and Indigenous groups that are familiar with more of the cultural burning and trying to implement that on our land. And also the rematriation of seeds, so our Indigenous traditional plants that are resilient on the prairie. We're looking at how we can harvest and store those so we can plant them back out on the land. So let's see. Yeah, we're just looking to build that resilience so that the prairie can be adapted to fire, drought, wind, and harvesting. Next slide. So Ini rematriation, that's happening as we speak. The buffalo are getting ready to make their way from Elk Island. This project has been in the works for almost 10 years now, and it has been supported by elders and the community and a lot of project partners. We're very excited to get out and document the changes that happen out in the land and with the community as the buffalo come home. So we've done some baseline assessments and sampling. We are creating a monitoring framework that includes our youth and community, and we're working towards ecocultural restoration. So looking at those treatments of prescribed fire, targeted grazing, and Indigenous traditional Blackfoot plants. Okay, yeah, the area has been degraded from overgrazing, recent fires that have gone through, And because the wind blows 130 kilometers per hour from the west, a lot of those agronomic species are coming in through that way as well. We've got some brome and Kentucky bluegrass that we're dealing with. Other invasives are the leafy spurge and knapweed down by the rivers. So looking at restoring those areas. Next slide. Some of the assessments we have been trained in are range and traditional plant surveying, water quality sampling, amphibian eDNA sampling, and bird surveys, which we've been doing for maybe 10 years now. So we're trying to get that complete baseline in order to monitor the changes from this point on. We're missing some of the things like soil health and insect and yeah, I think we're just looking to do like a complete baseline, but we haven't gotten everything in place yet. But yeah, we're working with the research center to get more funding for those things. Waterton Park has been amazing in supporting some of this training and getting the water quality samples processed and eDNA samples processed. So yes, we're very excited to see what changes happen out in the prairie ecosystem. Next slide. So a lot of our restoration work has been focused around traditional Blackfoot plants. We had some climate change sessions a few years ago that with the community that identified what concerns there were with climate change. What were people noticing as they saw more storms, even tornadoes happen out in the land, more invasive species come in, flooding, drought, and the common theme was traditional plant habitat loss. There is daily use of some of these plants, and when it starts to become scarce, it becomes almost a crisis, because this is a part of our way of life. So we are doing awareness around it. We've partnered with Y2Y to produce a traditional plants brochure. It's called A Guide to Culturally Important Blackfoot Plants, and we're sharing this with anybody who's interested in learning about a little bit of the Blackfoot names and stories, some of the stories behind them. So you can find this actually on buffalotreaty.com if you want to download it. And we'd like to get people out on the land, pending COVID, and yeah, do some plant ID with people. So we're building capacity, like I said, to harvest and store our native seeds. Working with elders and knowledge holders to build our traditional plant database to sustain plant abundance in grassland ecosystems. So we have a pretty extensive database right now that we're trying to figure out how to share information from and prioritize areas that need restoration. Next slide, please. The main threat, as I've mentioned before, is invasive plants, and that's mostly around our waterways, the rivers that border our reservation, the St. Mary's River that comes from the south, and a lot of knapweed and leafy spurge tend to travel along that way with it. So it's been a battle of balancing the chemical treatment and the biological treatments, and now we're utilizing targeted grazing with goats and hoping to get some good advancement there in controlling more of those infestations. But it's fairly new with the goats, so I'm not too sure how that's going to work. It looks good so far. Next slide. Community stewardship is a big part of what we do because we're based in community. A lot of the activities that we carry out in the land has to be in line with community values and just participation. So we've had lots of planning sessions on conservation and trying to figure out what's important to our community. What do they want to protect, conserve, and restore? Even just teaching that language, is new to most people. So yeah, we've got some ecocultural indicators that we've derived from these planning and awareness sessions with people. So hopefully that once we're all set up with a monitoring plan, we can get people out on the land using these indicators as monitoring change. Okay, next slide. So I just wanted to acknowledge all the partners that have helped us out over the past few years to build our capacity to do this work. It's been a fun learning curve. We've gotten a lot of people interested and a lot of knowledge gathered, and yeah, we just want to work towards doing best practices for getting things that are important back on the land, utilizing our traditional ways of knowing and being to be a more holistic restoration practice. So if you want more information, there is Napi's Garden and Keepa, and the website is napisgardenkeepa.com. I think it says there on the slide, Napi is spelled Naapis, garden, Keepa is KEPA.com. And you can reach Keepa members there and we'll provide updates. It's fairly new, so it's not fully running yet. Yeah, and if you have any questions, that's all I have for today.
Thank you so much for the presentation, Kanzi. We do have a couple of questions. The first one is, will traditionally harvesting the bison be part of this process?
Oh, yes. Yeah, it's a cultural herd, so it's going to be mainly used for bringing those cultural practices back to the community, and harvesting is one of them.
Okay, excellent. And then our next question, can you describe some of your ecocultural indicators that will help you monitor change?
Yeah, we have a few. So things like the beaver is like a very important cultural species, and they are also pretty good engineers of the wetland systems. So yeah, we want to find a way to document and monitor how they are doing out in the land, because it seems to be pretty scattered in their distribution on the reserve. Some people say there's too many, and some people say there's too little. And because they're so sacred, nobody wants to kill them. So nobody hunts them or eats them or anything like that. So it's a matter of relocating and seeing where they're needed on the landscape.
Okay, thanks for that answer. I know we're tight on time and there's a lot more questions. I'll just take one more minute and ask one if that's okay. And if you have some more time, Kenzie, maybe you could pop into the chat box after your presentation and reply to a couple. The last question is by a listener named May, and she said, is there an opportunity for settlers to help out with restoration as part of reconciliation efforts?
Oh yeah, for sure. We didn't have our annual summit, Keep the Summit last year due to COVID issues, and there still is a ban on people entering the reserve for other reasons than emergencies or passing through. But yeah, we're definitely trying to figure out how to do some online events and include anybody who's interested. You know, we're glad to share what we're doing and include others.
Thanks for that answer. I know we're tight on time. We've had lots of presenters this afternoon. So if you don't mind taking a few seconds to reply to any questions, Kenzie, and to all of our listeners out there, I know there's lots of extra questions in the chat box that our presenters are trying to reply to. And we can also carry that over into the open discussion room at 3:32. I'd like to call up our next presenter, Colleen Robertson. So, oh, yeah, we've got her slide. Perfect. I love when the technology works. So our last presentation for the session is Rangeland to Resilience, 50 Years of Fescue Grassland Monitoring in Riding Mountain National Park by Colleen Robertson and Raphael Otfinowski. I would like to make a note